All right, guys, we have a 2021 Chevrolet Silverado that the tailgate randomly opens by itself. Now, these have had, there's been a recall on some of them, and for water intrusion. They get water intrusion in this switch assembly, and it's shorting out the switch and opening the tailgate. It's either the switch assembly or the actuators, but these also are real bad about the switch going bad. Now, this one's working perfect at this particular time. I can hit the button and it'll open. And I've tried this multiple times so far, and it's worked every time for me. But the owner of this truck, he says that sometimes you can hear, even once it's open, you'll hear the actuator. In fact, I can simulate that by hitting the button. He said you can just sit there and listen to it clicking like that. So what my plan is, since I can't duplicate the problem, he actually had his tailgate tied to keep it shut, because sometimes he'd be driving down the road, sometimes it would just be parked. He said most of the time it would be parked, and then he'd come out and the tailgate just be open like it is here. I'm going to take this cover off. We're going to get access to the internals of this, and the first thing I want to do is take a look at the switch resistance. I'm going to meter the switch, see what the resistance is. So let me get this cover off, and all you got are some Torx. And what these are T20 Torx. Okay, and that's how quick you can access your switch. So the switch is actually right underneath this piece of metal here. This is the wire going to it. What my plan is I'm gonna disconnect the switch, get my meter, and I'm gonna ring the switch to see if it's got high resistance. I also just want to take a look at the other wiring, because basically all this switch is doing is providing a ground. When you push the switch, it's providing a ground to the BCM. Then the BCM is commanding the latch mechanism to unlock the tailgate. So in fact, if I hit the button right now, you can see what's going on. So there's a dual relay system. Whenever the BCM tells the actuator to unlatch, there's two relays. One is a power, one is a ground, and it provides, simultaneously provides a power and a ground to this actuator. So if either one of those relays were bad, this isn't going to work. Both of them have to be operational. Both of them have to get a command from the computer to actuate the mechanism here. So I'm going to undo this, all you got to do is pull that red little tab out, then it unplugs like that. So let me grab my meter real quick, check this. Obviously you want to look for corrosion or water or anything like that. And I mean, this looks dry, it looks fine. So let me get a meter. All right, guys, so I've got my meter. Oops. Are you on? Yeah, you're on. Let's see, I'll just sit, you can't see, I'm gonna set the meter right there. And all I'm going to do is just probe in here, and we're going to see what the resistance is of this switch. Should be wide open. This should not change at this point. That should stay exactly where it is. Okay, so we got 0.9 mega ohms. So the switch does does have a little bit of resistance to it. I'm going to go ahead and push the button. My assumption is it's going to go complete short. Nope, not complete. That's 1 mega ohm. So that's odd. And I'm not sticking these all the way in the holes, by the way, so don't roast me for that. In fact, I'm getting tired of having to stick them in here permanently. Okay, 0.6 mega ohm. I'm going to hit the button. 0.7, 0.7, 0.8. Okay, something happened there. Now it's 75 mega. Now it's 148 kilo ohm. So just by playing around with the switch, I am changing the values. Pushing, holding, okay, 38, 30, 28, 70. The switch is obviously bad. That should be wide open right now. Right now what we should have is that right there. Can you see that? Hopefully you're able to. I can't really tell if you can see the meter or not, but the resistance is going all over the place. This switch is definitely bad, without a doubt. So I'm going to see if I can get a switch. All right, guys, so the date today is February 2025, and this is the newest part number that GM has, 85734717. And if I was you, I'd try to get the newest part number, because typically what that means is they've made improvements or changes to the switch. And hopefully in this case, that means that it's a longer lasting switch. But anyway, so the first thing I want to do is compare this switch electrically to this one to show you what a good switch should look like. And we're going to do that in the garage. All right, guys, so I've got the meter, I've got the switch connector back probed, and you can see that on the meter currently we're just open. I'm going to push the button and we're completely shorted. 0.3. Open, closed, open, closed. That's a good switch. That's the way a good switch should work. That switch in the truck was all over the place. Just with it open, with me not touching it, the switch on the truck was like 0.8 or 9 mega ohms, and then once I started pushing on it and stuff, the lowest resistance I could get was like 47 ohms or something. And as I messed with it, it was all over the place. So that's a clear sign that the switch is bad, probably got corrosion and whatnot in it. So now the next thing is to replace it. So let's get that done. Okay, guys, so if you look right down these two holes, you got two 10 millimeters. So we're going to knock those out real quick. It looks like okay, so there's just clips holding it in right now. And once I get this out, I'll show you what I'm doing. As it's starting to rain on me. might have to hold on. I was taking those needle nose and I was just pushing that down, pushing those in a little bit to pop that out. So here's the switch right here. And I guess I should have, and luckily it worked that time. Guess I should have disconnected it before I. So I'm just going to push these two little tabs on each side. I've already got that one. And it looks like that is all there is to it. There's the old switch. So one improvement I hope they made was you can see that these little tabs right here are broke. Those two on that side's cracked. Hopefully they beefed those up a little bit. Both are made in Korea. But I'm just going to stick this back in. You got a little wire clip there. Go ahead and make sure you grab that. Shove the wires in. And you can see the little Now I'm going to go ahead and connect this. Probably shouldn't have opened or closed the tailgate, but I did. And there you have it. All I've got to do now is just put the cover back on, and this will be done. Dry my tools off. Anyway, it actually works better too, I've noticed. So the other one, I was having to really push hard. When it would work, I was having to really push hard. This one here, I just barely touch it. And you can see when you touch it, the tail lights come on and it opens up. Anyway, we're done. You know what? We're not done. Just to show you, for those of you that's curious, because I know you probably didn't see exactly what I was doing the first time when I was checking this. But right there, if you remember on the new switch, so I've got, this is the old switch, back probed. Without even touching it, it's 1.4 mega ohms. I want to push. And it's changing a little bit. Now I got 6 ohms out of it right there. So that's not too bad. But I let go of it. Now we got 389 kilo ohms. Push and hold. Not making. Nothing. Okay, the 230. Now we got 170, 285. So anyway, you get the point. This thing's just all over the place. So clear sign the switch is definitely toast. Even without touching it, we got 400 kilo ohms right there. So bad switch. You guys take care. We'll see you.